Hello students, this is a video for the topic test that we have designed for you. Now these topic tests are designed to help you gauge a level of preparation. So whenever you go through the basic concepts of a topic, you're advised to take these tests for that topic to understand how well you're able to recall questions, how well you're able to get those questions correct or apply those concepts that you've learned in a timed manner. Once you have attempted a test, there is a video for each test. The video tries to give you a perspective of what could have been a good attempt, what was the level of difficulty of the test, the kind of time that should have been put into the test, the questions that could have been chosen. And if you do like the tests and the video, there are more than 200 such topic tests available on the Bodhee Prep Android app. The app link is in the description below. Feel free to download the app and make use of these tests. This video specifically talks about time and work topic, and the discussion is about test number 2. Overall, this test was about a medium level of difficulty, a moderate level of difficulty, and a good attempt would be 6 questions. So, good attempt means net getting 6 questions correct would mean you will end up scoring up more than a 95 percentile. And the ideal time for this test would be about 21 to 20, 22 to 25 minutes. Higher side of 20 because there are some questions which require calculation. If we have a look at the questions, a tank can be filled by two taps, tap 1 and tap 2. The volume of the tank is 5,000 liters. Tap 1 fills the tank at 1 liter per second. Tap 1 liter per second, while tap 2 fills the tank at a rate of tap 2 3 liters in 2 seconds. So divide by 2, 3 by 2, 1.5 liters per second. On a particular day, tap 2 was opened for 100 by 3 minutes, after which tap 1 was opened. So 100 by 3 minutes, tap 2 is opened. After the time at which tap 1 was opened. Okay, sorry. On a particular day, tap 2 was opened 100 by 3 minutes after tap 1 was opened. So for the first 100 by 3 minutes, tap 1 is opened. 100 by 3 minutes, tap 1 is working. At this point, tap 2 is opened. If after 45 minutes from the time when tap 1 was opened, the tank developed a hole, which empties the tank at the rate of 42.5 liters per second. What proportion of the tank was full? Exactly 2 hours from the time tap 1 was opened. Now, if we look at the time, for the first 100 by 3 minutes, only tap 1 was working. After which tap 1 and tap 2 both were switched on. And this happened for a total of 45 minutes. So for how long were tap 1 and tap 2 both on? 45 minus 100 by 3. Because for the first 100 by 3 minutes, only tap 1 was working. 45 by 3 is 135. 135 minus 100 by 3, which is 35 by 3. So for the next 35 by 3 minutes, both tap 1 and tap 2 were working. Beyond this point, tap 1, tap 2, and the hole that developed, all three are operational, and the total time is 2 hours. So 45 minutes end here. So this goes on for another 1 hour 15 minutes. Now, what will be the amount of tank filled in the first two parts? 100 by 3 minutes. Tap 1 fills 1 liter per second. So 1 liter per second, therefore 1 into 60 liters per minute. Similarly, 35 by 3, we multiply this by 60 to get number of seconds. And when tap 1 and tap 2 are working, total they will fill 2.5 liters per second. So this is the amount that gets filled in the first 45 minutes. 2000 plus 20. So this will be 25, 50. That's the 15. 1750. So 3750 liters gets filled. Now, at this point, what proportion of the tank was exactly filled? Now, when we look at tap 1, tap 2, and the whole, tap 1 and tap 2 together will fill 1 plus 2, 1.5 liters per second. and the hole will empty 2.5 liters per second. So net, the change in the water level will be zero. So after this point, nothing or no change happens. Whatever water comes in, that water goes out. Until this point, we know that 3750 liters had been filled. So after 2 hours, also that is the amount that will be filled. So what proportion of the tank is filled? 3750 upon 5000. We divide by 1250. We get the answer as 3 by 4, option C. In terms of level of difficulty, I'd say a moderate level of difficulty. Solving time should not be more than 2 odd minutes, because essentially all we have to understand is we have to calculate 45 minus 100 by 3 and then multiply by values which are 1 or 2.5. After that, there is no change as it is. A certain job is assigned to three persons, Maxwell, McCullum, and Misbah, such that exactly one of them works on the job each day. The person who works on day 1 works on day 4, day 7, and so on. The person who works on day 2 works on 5, 8, and so on. So, in a way, alternate days 1, 2, 3, 1, 2, 3, 1, 2, 3. Day 3 works on 6, day 6, day 7, 9, so on. If Maxwell, McCullum, and Miswa work on day 1, 2, 3, the work gets over in 17 days. If Maxwell, Misbah, and McCullum work on day 1, 2, 3, in this case, it gets over in 16, 1.5 days. If McCullum, Misbah, and Maxwell, they work in day 1, 2, 3, the work gets over in 16, 1 by 3 days. Find the time taken. So let us first work with this. Now, if we compare these two situations, day 1, 2, 3, Maxwell, McCullum, Misbah, this process will repeat till 15 days. On the 16th day here, Maxwell will come to work, and on the 17th day, McCullum will come to work. Here, what will happen is till 15 days, this process will repeat. On the 16th day, we will have Maxwell, and on the 17th day, we will have Misbah. Now, till 16 days in both cases, work done will be same, because all three have worked for 5 days each. 16th day, Maxwell has come, so the amount of work done will be same. The only change happens here. On the 17th day, the work that Misbah does in half a day, McCullum takes the entire day to do that work, and therefore we can say that the ratio of efficiency of McCullum to Misbah will be 1:2. If McCullum does 1 unit of work, Misbah does 2 units of work, and therefore what McCullum completes in 1 full day, Misbah is able to do in just 1.5 days. Is in just half a day. Now, if we look at this case, for the first 15 days, in this case also, work done will be same as the first two cases, because all of them have worked for 5 days each. On the 16th day, McCullum will come to work, and then Misbah will come to work. So on the 16th day, McCullum suppose does 1 unit. Now, since here we have 1 by 3, what I'm doing is I'm making an assumption here. I am saying instead of 1 and 2, we can take the efficiency of McCullum to be 3 units. Misbah will be 6 units therefore. Now, on 16th day, McCullum will come and do 3 units. On the next day, Misbah will come and work for 1/3 of a day. Misbah does 6 units per day, so 1/3 of the day will do 2 units per day. That means after 15 days, 5 units of work is being done. Now, if we look at this scenario, Maxwell and McCullum, they would also have done 5 units in the last 2 days, because in the first 15 days, everyone is doing the same work. So, if 5 units of work is to be done and McCullum does 3 units, that means Maxwell will do 2 units in 5 days. Now, if we come to now we know the amount of work being done by Maxwell, McCullum, and Misbah. The work done by Maxwell, McCullum, and Misbah is in the ratio 2:3:6 units wise. The question says find the time taken if Misbah, Maxwell, and McCullum work on day 1, 2, 3. Now again till day 15, the amount of work done will be same, because everyone would have worked for 5 days each. What is left is 5 units of work is done, and on the 16th day, Misbah will come to work. Misbah can do 6 units of work, but only 5 units of work is to be done. So the entire day will not be required, only 5/6 of the day will be required. 5 units is to be done after 15 days when everyone has worked equally. And in this case, it is Misbah's turn. Misbah can do 6 units in a day. Therefore, 5/6 of a day will be required. So total time taken will be 15, 5/6 days, and that becomes the answer. Now, in terms of level of difficulty, I'd say towards a difficult level question, because the best way to do this will be to compare rather than form equations. If the comparison becomes a little visible, or you're able to spot that, then the question should happen in about 2.5 minutes. Otherwise, maybe not something that you want to do first time in an exam. 40 boys can construct a wall in 50 days, for which they are paid an amount of 3,000. Now, if an identical wall is constructed by 80 boys with the help of a certain number of girls in 20 days, find the difference between the total amount received by the 80 boys put together and that received by the girls put together. Now, if we say that one boy does 1 unit per day, so what is the total work for the wall? Total work for wall will be 40 boys will do 40 into 1 units per day, and they will work for 50 days. Number of boys, amount of work done per day, and number of days required. So 2000 units. This is what the wall requires to get made. Now, out of this, work done by boys is 80 boys doing 1 unit per day are now working for 20 days. So work done is 1600 units. And therefore, the remaining work done by girls, will be the remaining, that is out of 2000, 1600 is done by boys now. So 400 by girls. Therefore, we can say that the 3000 will be divided amongst boys and girls in the ratio of the work done, that is 1600 is to 1400, is to 400, sorry, or 4 is to 1. Amount received by 80 boys put together received by, and therefore 30,000, the amount that boys get will be 4 by 5. 1600 is to 400 is 4 is to 1. So boys will get 4 by 5 of 3000. Girls will get 1 by 5 of 3000. This becomes 3000. This becomes 6,400. This becomes 600. So the absolute difference between the two will be 2,400 minus 600, which is 1800 becomes the answer. Again, I'd say easy to moderate sort of a question. Just find the total work, and from there, a doable question should not take about more than about 2.5 minutes to solve. Working together, two workers complete a job in 8 days. At the first worker worked twice as fast as the second worker at a speed of one-third his actual speed. Okay, it would have taken 6 days. So first of all, let the work be of 24 units in total, and the two workers A and B be doing A does X units per day, and the second worker B does 3Y units per day. In the first case, when the first work they're working together, we can say X plus 3Y will be the work done in a day, and this will be nothing but 24 units being completed in 8 days. And therefore, we can say that X plus 3Y is equal to 3 units per day. In the second case, had the first worker worked twice as fast, so therefore does 2X units, and the second worker worked at a speed which is one-third his actual speed, so one-third of 3Y is Y. In this case, they would have done 24 units in 6 days. So 4 units per day. So we get the second equation, which is 2x plus y is equal to 4. This is equation number 1. This is equation number 2. In how many days will the second person working alone complete the entire job? We have to eliminate x. So what we can do is we can multiply the first equation by 2. So 2x plus 6y is equal to 6. 5y by 5. This becomes equation 3. Equation 3 minus equation 2. 2x cancel. 6y minus y. 5y is equal to 2. So y is equal to 2 by 5. And therefore we can say B does, or the second person does, 3 into 2 by 5 or 6 by 5 units per day. In how many days will the second person working alone complete the work? So number of days required by the second person will be work to be done 24 units. Efficiency of the second person is 6 by 5 units per day, and therefore 24 into 5 by 6 days will be required, which is nothing but 20 days becomes the answer. Option A. Again, in terms of level of difficulty, I'd say easy sort of a question. Basic steps are involved. The calculation might take a bit of time, and therefore the calculation time might reach 2.5 minutes. But conceptually, easy question, easy numbers also. P and Q can complete a certain piece of work in 24 and 36 days working alone. P and Q, 24 days, sorry, 24 days, 36 days. When working alone, they work on alternate days, starting with P. Further, they get a holiday after every 4 days of work, and after the holiday, the person who worked the last day before the holiday now starts the work. After how many days from the start will the work get completed? Let work be 72 units, LCM of or a multiple of 24 and 36, which means P does 72 units in 24 days, so 3 units per day, whereas B will be 72 by 36 efficiency, that is 2 units per day. Now, when they start working, first PQ will work, and then there will be an off or a holiday. So, in the first 5 days, the amount of work that will be done will be 3, 2, 3, 2, which is 10 units. Now, after the holiday, the person who worked before the holiday starts. So, for the next 5 days, you will have QP, and then there will be a holiday. Again, the same process will repeat 2, 3, 2, 3. So 10 units of work will get done. 3 plus 2, 5. 3 plus 2, 5. So we can say in 10 days, 20 units gets done. This process will repeat 3 times over the entire exact same thing. So in 30 days, 60 units gets done. Then we will have the next 5 days where P will start working. So basically, the first 10 days like this, another 10 days like this, another 10 days like this, 60 units. Then we'll start with P again. So in the next 10 days, that is 40 days, amount of work 60. In the next 5 days, not 10 days. In the next 5 days, we will have 10 units of work being done. So 35 days, we will have 70 units of work getting finished. After this being repeated 3 times, we will have this part that will follow. So 35 days are over, 70 units of work is done. Next, it is Q who is supposed to come to work, and amount of work left is also 2 units. 7 out of 72, 70 is done. So on the next day, Q will come to work and take the entire day to finish off 2 units of work, and therefore in 36 days, 72 units of work will get finished. 36 days, Q comes, or it is Q's chance to work. So Q will finish off 2 units and the work will get finished completely in full 36 days. Option B becomes the answer. In terms of level of difficulty, I think conceptually it's not a very difficult question, but it is easy to get confused in these questions, and therefore I'm saying moderate, about 2.5 minutes to solve the question. A plumber can finish job A and job C in 10 and 20 days respectively. A carpenter can finish job B and job C. So we can compare a plumber and carpenter here in 15 and 10 days respectively. So if we say that a plumber does 1 unit per day, job A will require a total of a plumber working for 10 days. So 10 units. Job C, on the other hand, requires the plumber to work for 20 days, 1 unit per day, therefore 20 units. Now, this job C is done by the carpenter in 2 days. So we can say that the carpenter does 20 units in 10 days, not 2 days, 10 days. So the carpenter does 2 units per day. And when the carpenter works on job B, requires 15 days to finish. So 15 days, 2 units per day, which is 30 units is what is required for Job B. On the first day, two plumbers begin work. And a day later, three carpenters begin work on job B. What is the least time required to complete all the three jobs? Now, total work to be done will be 10 plus 20 plus 30, 60 units. How is it being done? On day one, there are two carpenters working. So they'll do 2 into 1, 2 units in that day. Work remaining is 60 minus 2, which is 58 units. After this point, we will have two carpenters, so 2 into 1, plus two plumbers, so 2 into 1, and three carpenters, so 3 into 2. Plumber, carpenter working, and therefore 2 into 2, 8 units of work will get done. So if they work continuously and no one is resting, this work can get finished in 58 remaining work. So remaining time will be 58 units being done at 8 units per day, which is 29 by 4. And therefore total time will be day 1 plus 29 by 4 days, which is 33 by 4 days becomes the answer. Option A. Yeah. Overall, I'd say a moderate level of difficulty question. It is easy to get a little confused when the second work starts or when comparing, and therefore I'm saying moderate because again numbers are not very difficult. Maybe 2.5 2.5 minutes of solving time. Arun and Varun can complete a piece of work in 50 days and earn 28,000 in total. If Varun is thrice as efficient as Arun but leaves after 30 days, Varun is thrice as efficient as Arun. So suppose Arun does 1 unit per day. Varun is thrice as efficient, so should be doing 3 into 1 units per day. Okay. Varun complete a piece of work in 50 days. Varun but leaves after 30 days. So Arun has worked for 50 days and therefore we'll do 50 into 1. That is 50 units. Varun left after the first 30 days of work. So Varun works for 30 days. We'll end up doing 30 days, 3 units per day, therefore 90 units of work. Now, out of the total work, Arun has done 50, Varun has done 90. Therefore, the money will be divided in the ratio of the work done. A is to B, which is 5 is to 9. What is the amount Arun earns? Arun will earn 5 by 9, or 5 by 14, 5 upon 5 plus 9 of the total amount is what Arun will get. And therefore, 10,000 rupees is what Arun gets, and that becomes the answer. What is the amount Arun earns from the work? Because of the total work, Arun worked for 50 days at 1 unit per day, Varun 30 days, 3 units per day. So ratio work done is 5 by 9. Money gets divided in that ratio. So the answer becomes 10,000. Again, that's an easy question. Should not take more than 1.5 minutes to solve the question. Basic questions on wages and unequal efficiency. Three workers A, B, and C start a work. A is twice as fast as B, but only 1/3 as fast as C. Therefore, efficiency of A will be twice of B and 1/3 of C. 1/3. So what we can do is we can say let B be doing 1 unit per day. A is doing twice of that, so 2 units per day. And A is 1/3 of C. So if A is 2, C will be doing 6 units per day. A is twice as fast as B, but only 1/3 as fast as C. If all three of them together finish a work in 24 days. Now, when all three work done in 24 days will be 24 days, and every day 6 plus 2 plus 1 unit of work will get done. C, A, and B. And therefore, 24 into 9 units is the work that can be done. In how many ways can A and C, working alternatively for one and each day, complete the work? A and C. Now, here, if we look at it, if day 1 A comes to work, we'll do 2 units per day. On day 2, C comes to work, we'll do 6 units per day. And therefore, in 2 days, total work will be 8 units per day. Work done is to be 24 by 9. So 24 by 9, if we divide by 8, this is 27. So if we multiply this by 27, we will get in 54 days, we will have 27 into 8. This is 9 2s are 80, 9 to 30, 9 36, 116 units. This will also come out to 876, 856. 9 2s are 18, 9 2s are 36, 216. 216, 216, 216. 6, 24, remove a 2, 12, 9. 24 is 2 into 2 into 2 into 3. 9 is 3 into 3, 6 into 6 is 216. Okay. So this is 216 units. 27 into 8 will also be 216 units. So the work gets done in 54 days. Right? Also, if we uh, change the order, that is C works first and then A works, the order will change 6 and 2 units per day. But in 2 days, 8 units of work will keep happening. And since the total work is divisible by the work done in 2 days, the answer will not change. And therefore, whether A or C starts does not matter. The work will get done or will get completed in 54 days. In terms of level of difficulty, it's an easy question for the simple reason that total work was to be found out using the ratio of ABC, and then it was just to be divided by 8 and multiplied by 2. The steps are easy, conceptually not very difficult, and the numbers are not difficult, therefore I'm saying easy, but the attempt time will go up to 2 minutes, which is 3 men and 8 machines can finish the job in half time taken by 3 men and 3 machines and 8 men to finish the same job. Now, if we compare 3 men, or for the time being, if I write that, let one man do X units per day to avoid the M and M. One machine do Y units per day. Not days, but day. Now, 3 men and 8 machine will do 3X plus 8Y units. Can finish a job in half the time taken by 3 machines, 3Y plus 8 men, 8X. Now here the time taken is half of this. So we can say this efficiency will be twice of the other efficiency. The amount of work done in the first case will be twice the amount of work done in the second case. So 3x plus 8y is equal to twice of 3y plus 8x. Solving, we get 2y is equal to 13x. Now the question says if two machines can finish the job in 13 days, in how many men, then how many men can finish the job in 13 days? The work done by two machines in 13 days will be the same as the work done by 13 men in 13 days, because 2y is equal to 13x in terms of efficiency. So if the work that two machines do in 13 days will be the same as the work done by 13 men in 13 days. How many men can finish the job in 13 days? So for 13 days, the number of men required is 13, and that becomes the answer. If done properly, the solving time reduces. Rather than getting completely embroiled in equations, I stop my answer here, because at the end of this is the ratio that we are looking at. We get 2 by 13x, and therefore 13 becomes the answer. Work done by 4 men in 12 days is equal to work done by 6 women in 10 days. 60, 20, 48, and 60. 240 is also equal to the work done by 8 children in 9 days. 8 9s are 72. 48 and 60. 240, 360. 360, 480. 360. A man, a woman, and a child working together take 10 days to complete a particular job. In how many days the same job will be completed by 2 women and 5 children working together? Suppose a man does M units per day, a woman does W units per day, and a child does C units per day. According to the question, 4 men. So 4 into M into 12 is equal to 6 into W into 10. 6 women for 10 days is also equal to 8 children for 9 days. So 48M is equal to 60W is equal to 72C. We can divide by 24, 12. So 4m is equal to 5w is equal to 6c. Let this be equal to 30, 60k. So m will come out to 60 by 4, 15k. W will come out to 60 by 5, 12k. C will come out to 60 by 6, 10k. And therefore, the ratio of efficiency of a man, woman, and a child is 15 is to 12 is to 10. Assuming that a man does 15 units per day, a woman does 12 units per day, child does 10 units per day. In how many days will the same job be completed by? Okay. A man, a woman, and a child working together take 10 days to complete a job. Man plus woman plus child for 10 days is the total work being done. So we can say that the total work will be equal to MW 15 plus 12, 27 plus 10, 37 into 10, 370 units. This work is now to be done by 2 women, 5 children. 2 women means 2 into 24, 2 into 12. 2 women, 5 children. 2 women means 2 into 12. 5 children means 5 into 10. So 50 and 24. 74 units per day is the work that is being done now. So what will be the time required? Total number of days will be total work 27, 37, 74. 370 units being done at 74 units per day. This will end up taking a total of 5 days. 7 5 is 35, 20, 37. And therefore the answer becomes 5 days. I'd say moderate level of difficulty question because we start with the concept of ratios and then build towards the time and work application of unequal efficiency. Solving time could go up to 2.5 odd minutes. Overall, if you look at the test in terms of level of difficulty, as I said initially, moderate level of difficulty, 6 questions net should ideally happen. Solving time could go higher because there were questions where there was calculation involved. For me, my attempt questions here will be 3, 4, 6, 7, 8, 10. Which are these questions? This question, again, if I'm looking at a time test and I have a choice, I might actually leave this question because there was this difference in 45 minutes. There was a chance of confusion happening. Would have ideally left this in the exam, especially for the first time, unless I'm able to do other questions. This I would have done straightforward question. What day actual state of 6 days could have been done. Okay, equation based question. This could have been done. Would have done this because groups were made and according we were adding. This question there was an issue with the assignment of jobs per person. But I think eventually the numbers were easier. So out of 5 and 6, if we look at it, you could make a choice amongst 5 and 6. 7, again, wage-based was, I think, an easy question. Should have done this. 8, I thought, was also an easy question because the numbers were easy. This again, when you're solving it in a timed manner, there could be a problem because I stopped at 2x equal to 13y. But if you keep forming equations after that, it can get a little confusing. This again ratio based. So probably my attempt will be 3, 4, 6, 7, 8, 10. There could be a case where you say we could do 5 rather than 6. There could be a case where you see you do 9 rather than 10. But overall, about 6 attempts was something that should have happened in this test for an overall 95 plus percentile.